Then another thing to note, and this got a little cut off, sorry. Once you prove a theorem, you can use it as a reason in other proofs. So that's another nice thing. Okay, then we have some theorems. The first theorems here are kind of stuff we covered in section 2.4. So the first one is the reflexive property. Oh, also I should note that these theorems you should cut out and glue in to your notes, okay? So you don't have to copy them. If you want to, of course you can, but they should be on your sheet of cutouts to glue in. So the first one, reflexive. So again, that's basically saying anything is equal to itself. So it says for any segment AB is congruent to AB. So it's reflexive, like you're looking in the mirror at your own reflection. The second one is symmetric. And symmetric is kind of similar to the commutative property. Symmetric is saying you can change the order. If AB is congruent to CD, then CD is congruent to AB. Kind of like 2 plus 3 is equal to 3 plus 2. They both equal 5. So that's your symmetric. The reason why we have a different name rather than just saying commutative is that symmetric is really for geometric shapes, figures, angles, etc. Transitive, we also talked about. So again, if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. So I always think, like, if you just try a number, let's say AB is 5 and CD is 5, CD is 5 and EF is 5. If they're all 5, then we can also say that AB, right here, 5, is congruent to EF using the transitive property. Okay, and the properties for angle congruence is identical. It's just that now they're using angles in here instead of line segments, but basically the same properties. Okay, all right, let's go to the next slide. Whoops. Oh, we're to the examples, finally. Okay, so, whoops, here's the first example. And it might look familiar because it's kind of something we did the similar example in 2.4. Okay, so what you're going to do, it says and this also can be glued in. Write a 2-column proof for the situation in example 4 from section 2.4. So the reason it might feel like we're redoing this is that we want to expose you to that 2-column proof with a problem that you're already familiar with. So whenever you get this, you're always going to want to set up your T-chart, okay? Set up your T-chart. Okay, so, and again, statements always goes on the left. Statements, if you want to put S, that's fine with me. I'm not that picky. Reasons is going to go on the left. Okay, so let's start with what we know. Given, measure of angle 1 is equal to measure of angle 3. So typically in a 2-column proof, that's always what you are given. So right here, that should always be the first line in your proof. Okay, so line 2, since my goal is to prove that angle DBA is congruent to EBC, I need to kind of examine what I know about angle DBA. So angle DBA in red, as you can see, is equal to angle 2 plus angle 3. So I wrote that as line 2. Measure of angle DBA equals angle 3 plus 2. So pause for a second, see if you can figure out what the reason is going to be. All right, so let's see how you did. It should be angle addition postulate. Sorry about that. Angle addition postulate. Did I tell you this is my first video? So be nice. All right, then line 3. All right, now I'm also going to say that the measure of angle DBA is equal to angle 1 plus angle 2. So what I did here is I changed angle 3 with angle 1. That's what I did. So think, what lets us do that? What are we doing? We are basically substituting, because from line 1 said that angle 1 was equal or congruent to angle 3, and that was given to us. So I know that, so I can use substitution to substitute angle 1 and angle 3 interchangeably because it was given to me that they're congruent. Okay, then next I need to start thinking about angle EBC. We'll make that green. Angle EBC. So on the picture, if you look at that, angle EBC is equal to the sum of angle 1 and angle 2. And again, how do we know that? Same thing as line 2. That's the angle addition postulate. All right, line 5. So you always want to think about what was the question asking. If you look here, it's asking you to prove that angle DBA is congruent to EBC. So you're going to know you're done with your proof when you can do that. Also, hopefully if you look at lines 3 and 4 here, you're going to notice, oh, right here I have angle 1 plus angle 2. Here I have angle 1 plus angle 2. So I already have in my proof that DBA is equal to angle 1 plus angle 2, and EBC is equal to angle 1 plus angle 2. So if both of angle DBA and EBC are equal to 1 and 2, they must be equal to each other. So I'm ready to end my proof. The measure of angle DBA is equal to the measure of angle EBC. See if you can figure out the reason. And it should be the transitive property. If A is equal to B and B is equal to C, then A is equal to C. Transitive property of equality. And if you just want to put transitive property, that would be fine. Okay, so that is example 1. If you need to pause it or go over anything, please feel free to do so. All right, here's example 2. So for example 2, we're kind of starting with a 2-column proof. So again, you're going to see your statements and your reasons, and the T-chart is set up for you. We're kind of going to build our skills. So here we're filling in the blank rather than expecting you right off the bat to make a 2-column proof from scratch. All right, so let's look at the question. 6 steps of a 2-column proof are shown. Copy and complete the proof. Great news for you. This is also on your sheet of stuff to cut and glue in if you so choose. Then always look at what was given to you. Given. T, here's T, is the midpoint of line segment SU. Prove that X equals 5. All right, so let's look at what we have here. T is the midpoint of SU. See if you can figure out the reason. I think you should be able to get this. Hopefully you said given. That's always the first line of the proof. Okay, right there, what's given to you. Line 2, ST is congruent to TU. The reason, they fill that in for you, but eventually you're going to have to be able to do this on your own. How do we know that? Definition of a midpoint. All right, if you look at line 3 here, they're saying ST equals TU. Definition of congruent segments. Okay, so let's look at line 3. We did it in line 3. Let's look at line 4. 7x equals 3x plus 20. So how did we go from ST to 7x and TU and 3x plus 20? What did we do? So it looks to me like we substituted in 7x in for ST, and we substituted 3x plus 20 in for TU. So for my reason for line 4, I'm going to put substitution. All right, then let's look from line 4 to line 5. And if you look at the reason, if you're kind of like, well, line 5 is totally blank, look at the reason, subtraction property of equality. So that's a big hint that you need to subtract. So I would suggest subtracting 3x and subtracting 3x. So that is going to give you 4x equals 20 if we subtract 3x from each side. Then it looks like from line 4 to line 5 that they divided by 4 and they got x equals 5. So if they divided, your reason is going to be division property of equality. Okay.